Welcome back to Educator.com. This session is on for, or repeating with for loop. So far we have seen how to get data into a program, provide into a program, how to do arithmetic, and how to get some results. For example, get output from the program. In this session, we'll look at a new feature, repetition. This is implemented by the extremely powerful for construct. For starters, let's have an example. For I equals 1 to 5, display I, and let's try another one. For I equal to 1 to 0, display I, and end. So you see what happened. In the first one, loop goes from 1 to 5 and displays that number at each repetition till it finishes. For this one, Matlab wants to do the same, but there are no steps between 1 and 0, so there is no output. Let's have an example with some real problems, and that would be a square root with Newton's method. If you don't know about this method, don't worry. I'm gonna talk enough about that, and we're gonna come back to these different methods later on. The square root of any positive number may be found by using only the arithmetic operations of addition, subtraction, and division with Newton's method. This method is an iterative or repetitive procedure that refines the initial guess. To introduce in a rather elementary way the notion of structured programming, which we're gonna get back to it later on, let us consider the following plan. The structured plan of the algorithm is to find the square root of and a program with sample output, for example, for number 10. So first we need to initialize the number a10, and then we put a first guess or initial guess, which is x a over 2. Let's put semicolon as well. And then we want to do the repetition or iteration for, let's say, 8 times. And at each repetition, we put x, or the new value for our approximation, as x, the previous value, a over x, and over 2, because we want to calculate the square root. As I said, let's do it for 8 times. So for I equal to 1 to 8, x is evaluated like this, and have x displayed at each step, and end. Copy all these commands in Matlab command line. Let's also calculate the square root of 10. See what do we have after 8 repetitions. As you see, the result is pretty close. You should remember the value of x converges to a limit rather quickly in this case. Most computers and calculators use a similar method internally to compute the square roots and other standard mathematical functions. We're going to come back to this Newton's method later on. Next example that we're going to go over is factorials. Factorials are defined for all integers as the multiplication of all the integers before that number. And this is a perfect case for using for loop. For example, let's calculate factorial for n equal to 12. Let's start with factorial of 1, because the first integer is 1. Then for k 1 to n, which is the number that we want to calculate the factorial of. Fact is k multiplied by fact, and end, and let's have this display of fact. In this case, factorial. Copy all these lines into Matlab command line and see, Matlab calculates the 12 factorial for you. Do an experiment and find the largest value of n for which Matlab can find n factorial. We already seen what is the maximum value that Matlab can handle. So try to see what is the number that gives that factorial. The next example is to find the limit of a sequence. And for this example, let's try to find the limits of this sequence. Xn equals to a, which is an integer or a constant, over n factorial. The for loops are ideal for these successive computations, which we saw in Newton's method as well. As I mentioned, a can be any constant, and n factorial is a factorial function defined before. The question is, what is the limit of this sequence as n gets indefinitely large? Let's take the case as a is a constant. Let's do it on a scratch pad. When a is a constant like 14, if we try to compute xn directly, we could get into trouble because n factorial gets large very rapidly as n increases, and numerical overflow could occur. However, the situation is neatly transformed if we spot that xn can be written as a multiplied by xn minus 1 over n. There's no numerical problems now. This relationship between xn and xn minus 1 is a typical kind of discovery by clever mathematicians. Engineers and scientists certainly can be clever enough to discover these mathematical tricks. It is not, of course, expected knowledge, but it is a kind of knowledge that you gain through experience and through literature searches designed to help you solve mathematical problems that arise in your work. Now let's write the program. Assuming a is 14 and x start as 1, we want to calculate it for 20 or 30. So number of terms that we are going to calculate. For n equals 1 to k, x is a multiplied by the last value of x that we calculated, or xn minus 1 divided by n. This made our life way easier. And then display n, which is the last number, and x, and let's execute these commands in Matlab command line. Okay, all the values are calculated, and as you see, the limits for 20 is something like this. Now let's take a look at basic for construct. In general, the most common form of for loops in the program, not in the command line, is, since we're going to talk about program, let's have it here. For then indexes, for example, j or n from a certain number to another number, and then a certain statement, and end at the final line. Note the following points carefully. So n, or index, is a vector with elements from the first number added one by one and finishes at the last number. Index must be a variable. Each time through the loop, it will contain the next element of vector. And for each of these values, statements, which may be one or more statements, are carried out. We can also put increments as well. So for example, we can have n1 to k in steps of 2 or less. This is exactly how you define a vector. On completion of the for loop, the index contains the last value used. So after you finish going through all the elements in the array, n, or the index, will be assigned the last number or the value that you have in your array. If this vector is empty, for example, in this case k is smaller than 1, then statements are not executed and control passes to the statement following the end statement. You can also have the for loop in a single line. For that, you just need to add a comma at the end and have the end at the end of your statement. Let's try to execute this one line for. But notice that in good programming, it is better to have a visible way of writing your program. In that way, debugging would be way easier. So we covered the basic foreign construct and for in a single line. For a more general for, you can just have index evaluated to a vector or array that you have, or it can be a matrix as well. So by that, index will go through all the elements in the array or in matrix and execute the statements and give out the results. That was a more general for. A common mistake that many people do, especially at the beginning of programming, is using a for loop and they forget to put the for at the beginning. So let's have an example. Let's have a2 x is a over 2. This is the same program that we have for calculating the square root of a number. And then if you forget to put for, what happens is you basically defined an array for I. So you have an array for I which goes from 1 to 6, and then you go to the next line, which is x is equal to x plus a over x over 2. So you assign a new value to x, displaying it, and end. So it doesn't do anything special. It goes to all the commands one by one and give you a result, which, as you see, I is an array now, and display x give you the new value that you calculated for x. And since you don't have a for, end doesn't mean anything. So Matlab gives you an error for using that. Especially at the beginning of programming, don't forget to check everything and use for loop in the way that it's supposed to be. Thank you for being with us. This session on Matlab brought to you by Educator.com.